Good morning, everyone. As Penny says, my name is Graham Hunter, and I work in the business services team here at the Carbon Trust. So just to give a brief introduction, I'm actually a member of the technical delivery team here. So most of my role involves providing support to clients on energy efficiency and renewables projects. And over the last couple of years, I've been fairly heavily involved in Green Business Fund. So that's been through a mixture of either running workshops or actually carrying out energy audits or providing procurement support to SMEs. So that's me, and here is the agenda for today's session. So firstly, we'll give a brief introduction. Then we'll begin with a breakdown, having a look at typical energy consumption in schools. We'll then have a look at energy management best practice, specifically for schools. Then we'll move on to the bulk of the webinar, which is having a look at the various energy saving opportunities that exist in the majority of schools. And we'll also have a look at a couple of case study examples of schools that we've recently supported through Green Business Fund. And finally, we will finish off by just having a run through the key aspects of the Green Business Fund. So first of all, just a bit of an introduction for anyone who's not overly familiar with the Carbon Trust. So we are a not-for-profit organisation that was set up in 2001 with a mission to accelerate the move to a sustainable low-carbon economy. There are essentially three elements of what we do at the Carbon Trust. So they can be broken down into advice, where we advise businesses, governments, and public sector clients on their opportunities in the low carbon world. Footprinting, where we measure and certify the environmental footprint of organizations, products, and services. And technology, where we help to develop and deploy low carbon technologies and solutions. So Green Business Fund that we're here to introduce this morning would fall under the advice section here. So the aim of the webinar today is to, first of all, improve the understanding of energy use in schools, and also have a look in brief at the difference between high energy use systems versus systems that will be more expensive to run. We will hopefully develop an understanding of how improved controls, management practices, or new technology can deliver cost-effective energy savings. We'll also use some case study examples to illustrate this. And finally, we will give an introduction to the Green Business Fund and the various services that we can offer to schools. So first of all, if we start with an overview of typical energy consumption in schools. So energy consumption in schools can obviously vary, typically depending on factors such as the age of the building, its state of repair, its occupancy hours, and also quite often the amount and type of electrical equipment that is actually installed. Generally, however, secondary schools tend to have higher running costs than primary schools, and this tends to be due to the longer hours and larger number of students in secondary schools as opposed to primary, and also can be due to just more widespread use of different types of electrical equipment. So in subjects, for example, such as ICT or craft subjects. The pie charts that you can see on the slide here are actually from the Carbon Trust Guide for Schools, which I would recommend having a look at following the webinar for a bit of follow-on advice. What we can see here, I've just put this up as a bit of an example to sort of kick things off. These are quite useful actually, particularly for people like school managers, just as a sort of quick reference guide as to where the largest savings opportunities might be. So to give an example of that, if we look at the pie chart on the left-hand side, figure 1A is showing percentage energy use breakdown in a typical school. And we can see that lighting accounts, in this case, for 8% of the energy use in the school. If we look at the pie chart on the right-hand side, as a comparison, we can see that lighting here actually accounts for 20% of the total energy spend of the school. So with lighting only being 8% of the actual energy use, but then 20% of the total energy costs at the school, it's probably no surprise that upgrading or improving lighting is typically one of the measures that we see schools looking at first of all as one of the most cost-effective energy efficiency improvements they can make. Similarly, there are other comparisons that you could also do with this these pie charts. So as I say, the Carbon Trust Guide for Schools is quite a useful start point. We'll now move on to have a brief look at some energy management best practices in schools. So I thought it would be useful just before we start to look at any specific technology areas, if we just very briefly touch upon some of the basics of energy management in schools. This will obviously be a very quick overview. For anyone who's interested in looking at energy management in a bit more detail, I would actually recommend that there's another webinar which is currently available on YouTube. So that is a Green Business Fund webinar entitled Managing Energy as a Controllable Resource. So I would suggest having a look at that, as well as there's also a couple of different Carbon Trust guides on energy management as well. But on this slide here, we've laid out 4 key action areas that are specific to schools. So those are defining responsibilities, developing and implementing an energy policy, recording and understanding energy consumption, and undertaking regular housekeeping walk rounds. So when we speak, first of all, about defining responsibilities, in a school, this would typically be in the form of establishing either an energy team or an individual with responsibility for energy management. If you were to implement an energy team, then we would suggest this should ideally comprise members of staff at all levels, so from management to teaching staff, to maintenance staff, and cleaners as well. And we'd also suggest involving students in this. So the role of an energy team would typically be to stay on top of energy management, to ask staff and students alike to report any issues, so just anything that they observe around the school, and then also ask maintenance and cleaning staff, so maintenance staff potentially to monitor and to adjust any control settings on systems such as heating and cooling, and cleaning staff just to report anything that they observe, maybe when they're in early in the mornings or at night, if they're noticing things like lights being left on in areas that aren't being used, for example. Following the establishing of an energy team or an energy manager, the next step would usually be to develop and implement some form of policy. So that could be a separate energy policy if maybe you were a larger school. Smaller schools would tend probably to have just an environmental policy that might make mention of energy within it. Um, so, but typically what we would expect to see from an energy policy would be first of all, a statement of commitment to reducing energy use and the environmental impact of the school. To set clear objectives and targets to try and reduce energy consumption. So that could be something as simple as a percentage total energy use reduction per year. To identify who is actually responsible for achieving those targets and what resources will be made available to the person or persons with that responsibility. And also to set out a time frame for review. So it's important just to make sure that policies, once they have been implemented, do remain relevant and appropriate. It's also important to record and understand the energy consumption at the school. So this would typically be done by reviewing any invoices for example, gas and electricity consumption, and also reading meters as well. Quite a useful exercise is also to just compare the figures on the invoices with the meter readings, especially if you are being billed on estimated usage. What you can find is that is typically a lot higher than maybe what you are actually using. So it's always worth just making sure that you are being billed correctly if you aren't on a smart meter or you don't have half-hourly energy data. Those meter readings could be recorded using meter reading sheets, and then another useful exercise is often to actually plot that energy consumption over time, so that you can assess any trends that you can see in the energy use. So they might be seasonal trends, or they may be just daily trends where you see energy use peaking during the daytime and then dipping overnight. Finally, on that point, another useful exercise is often to actually measure the performance of the school against your peers. So you could do that by creating some energy use benchmarks. For example, if you wanted to look at gas or electricity or oil use in terms of kilowatt hour energy use per square meter, that's often a useful benchmark to then compare against the same benchmark for similar types of schools, no matter what size they are. Finally, on energy management, I just want to highlight the usefulness of undertaking regular housekeeping walk rounds as well. So this is something sounds like a fairly basic exercise, but can actually be very, very useful. What that does is it establishes, first of all, what the current operating practices are within the school. So for example, when different areas are heated, when any lighting is switched on in intermittently used areas. And then based on the observations on the walk rounds, there is obviously the opportunity then to try and eliminate any wasteful practices and identify opportunities for energy savings as well. And walk rounds are also a good opportunity to involve both staff and students. So while they may be led by a member of staff or an energy manager, there's no reason why students couldn't become involved in actually carrying out the walk rounds and collecting some of the data. So as I say, that's just a very, very brief overview of a couple of first steps into energy management. What we'll now do is we will move on to have a look at some of the key energy using systems that tend to be found in schools. And as we go along, we'll also look at some of the potential opportunities that exist within these systems to try and achieve energy savings. So we'll start by having a look at heating, as this is typically the largest and most expensive energy user in a school. So on heating, we've highlighted here just a few things that should be considered. So the first one there is temperature settings. So children tend to have actually higher metabolic rates than adults, which means that they are actually comfortable at lower temperatures. And there are some guidance notes on this from the Department for Education and Skills. So they actually recommend a classroom temperature of 18 degrees Celsius and a circulation space temperature of 15 degrees Celsius. So one useful step in schools might be just to compare the settings that you actually have programmed into your heating and cooling systems just now, and make sure that they are in line with those guidance temperatures. Heat only when needed. So heating needs tend to vary throughout the day and throughout different areas of the school. So it's always worth just checking that the system operating hours actually match the times that the heating and ventilation systems are programmed to be on. One thing you find sometimes is actually that systems might be functioning fairly inefficiently just because maybe someone has made a short-term adjustment to the heating system and then forgotten about it. So actually you end up with areas of the school that are being heated for longer than is actually required. So there's a quick win, zero cost saving potentially to be made there. Checking thermostats regularly as well. So we would also advise discouraging staff from turning up thermostats. It's a bit of a typical misconception that turning up the thermostat means that the room heats up quicker. What tends to happen when that's done is actually that the room will heat up at the same pace that it would have if the thermostat was at a lower temperature, but it will then obviously just continue to heat the room, potentially causing overheating, and then we see things like windows being opened while the heating is on, which leads to wasted energy. It's also important just on thermostats to make sure that they aren't influenced by any external factors. So for example, that they're not next to any drafty windows, or not in direct sunlight, or a fairly common one that we see in offices and schools is sometimes printers being situated below thermostats, which may result in the classroom temperature actually being lower than desired because the thermostat's getting all the heat from the printer, so it thinks that the classroom is actually warmer than it actually is. It's also important to keep systems clear and unobstructed. So just make sure that radiators and vents aren't obstructed by any equipment, that filters are kept clean and free of dust as well. So this just ensures better circulation of heat into the space, and by clearing filters, that then reduces the energy required to meet the heating demand. So if you have clogged up filters on HVAC systems, then what tends to happen is that the motors just run, so they have to work a bit harder. So then you're getting excessive energy use where it's not necessary. It's also important to ensure that boilers and pipework are maintained. So by law, gas boilers should be serviced at least once a year. Oil boilers should be serviced twice a year. and we regularly see savings from effectively maintaining boilers, typically around 10% per year, cheaper to run than boilers that aren't as well maintained. It's also important to ensure that controls are up to date and effective. So heating controls, particularly in older buildings, can tend to be quite problematic and fairly inefficient. There are, however, various types of controls currently on the market um, that offer quite a lot of automation. So just a couple of examples of those. So a weather compensator would be one device. So it's a form of control for a heating system that essentially automatically regulates the temperature inside the building based on the external temperature, meaning that the boiler is not working quite as hard, and so there is an energy saving there. A similar type of heating control would be an optimum start controller. So this is a device which learns how quickly the building reaches the desired temperature. So sort of like a smart thermostat. And then it will perform its own calculations and bring on the heating in the morning prior to building occupancy, um, based on a couple of different things. So it will monitor what time it's been switched on the previous day, and it will also measure the external temperature again to make sure that it's not coming on too early and that the building isn't being heated earlier in the morning or later in the evening than it needs to be. And just a couple of case study examples on heating. So the first one here is a school in Bishop Stortford. This is one where they upgraded the boiler controls. So that came at an investment of £6,000 and resulted in a heating cost reduction of 21%, which meant that the school saw a return on investment in under 4 years. Another school who came to us were Broomhill Primary School in Aberdeen. This was one where they were actually building a nursery extension onto a primary school, and they wanted to look at how that could be done in the most efficient way. So they installed separate zone controls, bearing in mind that the nursery occupancy hours would be a lot shorter than those of the primary school. They made sure that they had separate zone controls in the primary school. They also took the opportunity while this work was going on to carry out a couple of additional measures. So they installed draft stripping to the windows and doors, and they also installed timers on ventilation fans, which was something that they noted were running for longer than they needed to be, and therefore wasting energy. So all that work resulted in a saving of over £1,000 a year for the school. We'll now move on to have a look at hot water systems. So these are actually systems where you almost are penalised twice in a way. So as a school, you tend to be paying for both the cost of heating the water that's being used, and separately you'll also be paying for the amount of water that you're also that is also being used. So there are a couple of suggested measures on the slide here. So the first thing you might want to look at would be installing percussion taps. So these are quite simply just hot water taps that switch themselves off automatically after a set amount of time. Another thing you might look at there would also be to install low flow taps as well. So they just, while they are switched on, they reduce the amount of hot water that is coming out of the tap. dealing with dripping taps and leaks is something that should form part of a maintenance program. So just making sure that any issues with leaks are being addressed as quickly as possible. Insulating hot water storage tanks and distribution pipework again is something that should always be done. That might be something that you could identify on walk rounds of plant room, for example. And it's something that it's very, very cheap to buy insulation for both hot water cylinders and pipework. Therefore, you get a very quick payback on quite a small investment there. It's also important just to check that, first of all, you have time switches and that hot water isn't just available 24 hours a day, unless obviously that's something that is necessary, although typically we find hot water demand is only really something that exists while the school is actually in operation. And so time switches are something that can be installed again at fairly low cost. So these could automatically be switching the hot water systems off overnight and then coming back on in the morning in time for cleaning staff to come into the building who will require the hot water. Just on that point as well, if you have cleaning staff in the school, say over weekends or especially school holidays, where the school is unoccupied for quite a length of time, then it may be worth considering whether actually running the central boilers is the most efficient way of providing hot water for the purposes of cleaning the school, or if it might be more efficient actually to install something like point of use electric hot water heaters, which would then allow the main systems to actually be shut down for a period of time, say for example over the summer holidays. So we'll now move on to have a look at opportunities for improving the building fabric. And this is important because typically around 2/3 of heat loss in a school building is actually through the building fabric itself. So most of that being through the walls, floors, and ceilings. So it obviously makes good sense to make improvements in this area. So again, just to run through some improvement measures that could be implemented. The first thing that we would generally suggest would be to establish a housekeeping schedule. So this could be just a simple checklist of areas to address in terms of assessing the building structure and the building fabric. So things that could be checked on a fairly regular basis would be things like window panes and frames, making sure that they are structurally sound and there are no draft issues. Same, having a look at any skylights, making sure that there aren't any issues with leaking roofs, and checking that there are no drafts coming from skirting boards and the eaves. It's also important, once any issues have been identified, obviously to make sure that regular maintenance does take place. So good building maintenance requires that the potential problems are identified and dealt with promptly. In particular, just any gaps in the building fabric that should really be addressed as quickly as possible. It's also important to just make sure at the same time that the building is being checked for damp, particularly because damp can actually reduce the insulation properties of any insulation materials that are already there. So it's worth at least once a year, preferably just prior to the winter months, just making sure that there are no damp or condensation issues within the school. It's also important to check and maintain any insulation. So as we mentioned already through the heating and hot water, just make sure that all pipework is insulated. At the same time that any accessible loft spaces are insulated. And also, if there is insulation there, then it's still worth just checking that it is in good condition and is not in need of either replacement or topping up. As well, it may be worth having a look at improving any glazing that you have in the school. So particularly if you have any remaining single glazed windows. If you are replacing windows, then the minimum requirement just now is to install double glazed windows. Although sometimes it can be worth looking also at triple glazing as an option. Particularly if you have either a large number of north-facing windows that don't get very much natural daylight, or if you just have a lot of exposed windows. Installing more insulation during refurbishment as well is just something to highlight. So if you are adding any extensions to the school, for example, or if you're just upgrading areas of the school, then this is quite often a good opportunity just to look at any improvements that can be made to the building fabric. If there is work already being carried out by contractors, then quite often one of the benefits of that is that you may be able to sort of look at fairly marginal costs for improving the standard of insulation. And finally, on building fabric, just to highlight that draft lobbies are something that we have seen a couple of schools look at fairly recently. So this is where you are essentially just adding a lobby onto any frequently used entrances that are causing draft issues in the school. So it's just need to make sure obviously that these draft lobbies are large enough to still provide unrestricted access to the school and enable one set of doors to be shut at all times. And on the case study here, so as I say, we did have one school look at this fairly recently, a school in Wales who installed external draft lobbies, and they saw a return on investment on that of under 4 years. Another school we looked at was a primary school in Kesgrave, where they installed a suspended ceiling in a area of the school where they had very, very high ceilings. So essentially we're heating a large volume of space and had a bit of an issue with thermal stratification. So a lot of heat just sitting below the ceiling. So they actually installed a suspended ceiling, which was then insulated, and at the same time they installed some cavity wall insulation as well. So the investment there was around £10,000, and that resulted in a saving of over £1,000 a year. So the school there saw a return on investment of just under 10 years. We'll now have a look at some of the opportunities involved in lighting. So as we looked at on the pie charts at the beginning, lighting typically accounts for somewhere between 8 and maybe 12% of the total energy used in a typical school. However, there's still quite a considerable scope within that to make energy and cost savings, just based on the fact that lighting tends to be quite an expensive part of that energy use in the school. So the first thing to highlight here is quite simply just to make sure that any lighting is switched off when not in use. It's also a fairly common thing that we see in schools, as illustrated on the slide here, is this scenario of blinds actually being drawn to control the amount of glare that's coming in from outside. So where possible, what we would suggest is just to encourage staff to actually use blinds instead of pulling them all the way down to try and direct that daylight onto the ceilings and the walls in the classroom, which will hopefully reduce the need for electric lighting in the classroom at the same time as trying to reduce that glare. Also, just make sure that any lamps that fail are replaced as soon as that is identified, just to make sure that the illumination levels in the school are as they should be. Something that's also a sort of fairly simple low-cost measure that can potentially have a significant impact on lighting costs is just to make sure that light switches are appropriately labelled. So essentially helping out staff and students to just make sure that they're only switching on the lights that they intend to, and they're not switching on a whole grid of light fittings when they're only actually intending to switch a couple on. Also, something that may be a fairly significant investment, but where we do see fairly large energy savings would be to install LED lighting. So typically just now with LED lighting, we are seeing savings of 60% and upwards. And this could be this could be something as simple as just switching out incandescent light bulbs for LED equivalents, or it could be something as involved as an actual redesign of the lighting systems in the school. So potentially reducing the actual amount of light fittings, as LEDs give off a lot more light than traditional fluorescent light fittings that we tend to find in schools and offices. If you are looking at installing LEDs, then this often also brings up another opportunity, which would be to look at different types of automatic lighting controls. So this could be something as simple as a time switch with a manual override, or it could be something a bit more high spec. So for example, daylight sensing technology, where the light fittings will actually dim depending on the amount of light coming in from outside, or for intermittently occupied areas, so say storage areas, maybe any gym facilities, or any bathroom facilities. You could also look at installing automatic motion sensors. So just to make sure that when spaces aren't occupied, that they are that the lights are actually being switched off. And just a quick case study on the lighting. So I thought this was actually a good one to highlight. So this is a primary school that we worked with to install ceiling-mounted LED fittings, as well as occupancy and daylight sensing controls. Now they actually only achieved a relatively small saving of 30% on their lighting energy costs. What that figure doesn't tell you, however, is that when the lighting contractors actually went to site and looked at the lighting levels in the various areas of the school, what they actually found was that lighting levels were a lot lower than the guideline levels for each of the different areas of the school. So the main benefit there of the LED lighting was actually to just provide a better quality and a higher level of illumination in the school. And they also, in addition to that, managed to achieve a 30% saving on their lighting energy costs. So now we'll have a look at a few areas that are maybe a little bit more specific to secondary schools. So first of all, we will have a look at catering and food technology equipment. So the first thing to highlight here is just to make sure that equipment is always purchased with running costs in mind. So examples of that might be installing gas-fired equipment, which typically tends to be more expensive to buy than the electrical or steam equivalents, but actually you'll tend to find costs a lot less to run, making it a much more efficient option for the school in the longer term. It's also often worth looking at equipment that automatically switches itself off. So that would be things, for example, like pan sensors on hobs that switch off when there is nothing sitting on top of the hob. It can be also very useful with particularly commercial kitchens to look at installing some sub-metering. So essentially just having a separate meter that's recording the energy use of that kitchen facility. So this first of all helps you to establish what the energy costs of that facility are. And then obviously you can have a look at trying to make adjustments to try and reduce those running costs. We tend to find that's particularly useful in schools where maybe you have an external contractor who's providing catering facilities, and they are not responsible for the energy costs. And so if you did want to look at trying to incentivize contractors to try and reduce the amount of energy that they are using, then it's often worth, first of all, just sub-metering to work out exactly what that energy use is. Considering heat recovery is something that is often worthwhile as well. Just bearing in mind that school kitchens tend to expel fairly large volumes of warm air, which can often be recycled. We tend to find as much as 50% of exhaust air can be recycled from commercial kitchens, and this is typically used to heat water, which can then be used in other areas of the school. Just also a quick note on so two technologies which tend to account for the majority of the energy use in catering and food technology. So cookers, so ovens and hobs tend to use quite a large amount of energy in a school kitchen. Particularly larger schools where we often find that cookers are used for more than 10 hours a week. So a couple of things there might be to look at making it policy, for example, to only use microwave ovens where possible, as these are a lot quicker and a lot less energy intensive than regular ovens. It's also important in catering facilities just to make sure that ovens aren't being switched on first thing in the morning and then just being left on all day long, which again is something that we tend to see fairly regularly. Within refrigeration, there are a couple of things we can look at, just bearing in mind that fridges and freezers tend to consume fairly significant amounts of energy as they're used for 24 hours a day, 7 days a week. So you may look at positioning fridges and freezers away from any heat sources like cookers, just to make sure that they can run as efficiently as possible. Making sure that thermostats are set at the right level for the contents. Checking that any door seals are intact, just so that any cold air isn't escaping. Encouraging staff not to open doors or leave any doors open unnecessarily. To make sure that freezers are being defrosted regularly to make sure that they are running at their optimum efficiency. And also one thing that might be worth looking at would be if any fridges could be switched off during the school holidays. If it's not possible to switch off any refrigeration equipment, or sorry, if it's not possible to switch off all the refrigeration equipment, then maybe you might be able to look at something like consolidating all of the food into one fridge, for example, meaning that at least some of the fridges could be switched off while the school's not occupied. And a case study here on catering and food tech equipment. So this was a primary school where they installed various different measures. Some of these actually were just energy management systems that they implemented. So they improved their standard of energy monitoring of the catering facility. They replaced a sterilizer with a dishwasher. They established kitchen warm-up times, so just making sure that ovens, for example, aren't being switched on earlier in the morning than they need to be. They reduced the use of hot water cupboards. They fitted insect mesh onto the windows so that windows could actually be opened, improving ventilation and reducing the need for mechanical ventilation. And they also made sure that regular maintenance was carried out on key pieces of equipment as well. The result of this being that they saw an energy saving of around 30% on the commercial kitchen energy use. They also achieved a bonus, if you like, water consumption saving of 25%. And they saw a 33% increase in the meals produced by the kitchen just by implementing some more efficient practices. So we'll now move on to have a look at some other areas of the school where electrical equipment is in fairly heavy use. So the first one to have a look at is ICT equipment. It's an area where we see in some schools it can actually account for quite a high percentage of the annual energy costs of the school. So some tips here would be, first of all, just to make sure when not in use that equipment is actually switched off and powered down. This also would have the added benefit of hopefully ensuring that equipment actually runs longer if it's not being used as much. As we've mentioned with hot water systems previously, it may be worth looking at installing 7-day timers just to make sure, as above, that the equipment isn't being used when it's not required. It's also important just to match the equipment to the task as well. So, for example, there seems to be sometimes a bit of a trend to invest in higher spec printers than are actually necessary, which tend to have quite a high electrical load. So just making sure that you're not using equipment that you don't need to be. And on a similar note, just making sure that you are also purchasing for the requirements of the school. So we'll also just have a quick look here at some electrical equipment that we tend to find in science, technology, and craft facilities. So first of all, in order to try and manage the energy use in these subjects, the first step we would suggest is just to make an inventory of all the curriculum-based equipment that the school does actually have. So this curriculum should typically include the number of each type of item that the school actually has, and then make a note of the location of these items as well. And then also it should assign responsibility for the maintenance of those items to an individual or to a small team. I've also highlighted just a couple of pieces of kit where we typically see fairly high energy use. So the first one there is fume cupboards. So not only do fume cupboards use quite a lot of electrical energy to drive the fan, they also remove warm air from the lab, which obviously then just increases the need for space heating in the lab facility. They are obviously something that is essential just to avoid hazards. But at the same time, there are some fairly simple procedures that you could follow to just make sure that they're not resulting in excessive energy use. So for example, just quickly, just making sure that the right sash height is being used. So an inappropriate sash height is something that can increase the energy use of the fume cupboard, as well as also putting users at risk of ineffective extraction of the fumes as well. It's also important to make sure that fume cupboards aren't just being used as bench spaces, so just make sure that the cupboards are only being used for stages of the experiment where hazards are actually present. And also make sure that they are switched off when they're empty or when they're not in use. And avoid storing any chemicals in fume cupboards. Chemicals should ideally be stored in a dedicated chemical storage cupboard. Also, just make sure that kilns and small power equipment are also being used efficiently as possible. So make sure that kilns are fully loaded before firing and that they are cleaned out as per the manufacturer's instructions to make sure that they perform as efficiently as possible. Just bearing in mind that kilns are very heavy electricity users. Also, maybe worth considering whether kilns can be fired overnight or at weekends as well, when the total electricity load of the school is at a lower level. Also, just to touch upon audiovisual and music equipment, as well as vending machines and water coolers. So with AV and music equipment, again, it's just important to make sure that these are being switched off when not in use. And when they are in use, just make sure that these are being used on the right settings. So sometimes what you might find, for example, is that programmable equipment may lose its settings when it's properly switched off. So just make sure that these are set up to go into standby mode when not in use, for example. Also on vending machines and water coolers, these are things that we tend to find in schools, may be installed by an external contractor, and are just set up to run 24/7. So it's always worth just making sure that so vending machines that aren't storing any produce that needs to be refrigerated can quite easily, just with an automatic time switch, as shown in the slide here, just be switched off at nights and weekends automatically. Also, there may be the opportunity there just to speak to the supplier of the vending machines, just to make sure that you do have the most efficient equipment that is available. Next, I just want to give a brief overview of the opportunities that exist in schools where we have swimming pools. Again, if anyone wants a bit more detail on opportunities with swimming pools, I would probably refer back to the Carbon Trust guide, specifically on swimming pools. But I've just highlighted some key opportunities here. So the first one that we would flag would be to always make sure that swimming pools have a pool cover fitted when they're not in use. So swimming pools, depending on whether the school maybe is part of a community facility, may have shorter or longer occupancy hours of the swimming pool. But one thing that we again tend to see is swimming pools just being set up to maintain a 24-hour heating and ventilation regime when they're not actually being occupied for 24 hours a day. So using a pool cover overnight, if this is the case, is something that can potentially actually save even up to tens of thousands of pounds, depending on the size of the facility. So that would obviously reduce the need for heating, both in terms of heating the pool water and heating the pool air itself, and also reduce the need for pool hall ventilation and make-up water as well. It's also important to schedule backwashers and just make sure that backwashing of pool filters is only done when required, as again, this is a fairly costly thing to do. We would suggest always speaking to the manufacturer of the pool equipment to make sure that you are maintaining an optimum maintenance regime for the pool. It's also important to maintain comfortable pool temperatures. So swimming pools tend to be heated somewhere around 28 to 30 degrees Celsius, which is obviously very high. And to reduce condensation in the pool, the air temperature above the pool should also be set to about 1 degree above the water temperature. So these relatively high temperatures obviously can result in fairly high heat losses from the pool hall that need to be replaced. So it's important to make sure that these temperatures are closely regulated, and this can be done by installing controls which regulate both the pool and the air temperature, and also control ventilation using variable speed fans. So you may want to look at, for example, installing humidistat, which could be installed within the pool hall to make sure that ventilation is only switched on when the relative humidity within the hall rises, say above a certain level, typically somewhere between 65 to 70%. It may also be worth exploring the potential for solar water heating or solar thermal technology. This is something that can be quite effective for swimming pools. It's relatively cheap to install and connect to a conventional heating system, and it's something that tends to be used in summertime. Potentially it can actually fulfill all of the hot water needs of the pool, and through the autumn and winter months it can be used as a top-up to more conventional water heating systems. As with the exhaust air from the catering facilities, there is also potential to recover heat from the ventilation air from the pool hall. So that's another opportunity that may be worth looking at. And again, that warm air could potentially be recycled to provide hot water, say for example to the shower facilities in the swimming pool area. Finally, on swimming pools, something that we often find ourselves recommending on energy audits would be to install some submetering to the pool facility. So there we're probably looking, rather than submetering electricity use, to submeter the use of either gas or oil, as well as the electrical supply, to try and obtain some more exact information on just how much the facility is actually costing to run. It's worth taking meter readings at hourly intervals when the pool is occupied. Also worth taking some meter readings if you can at the beginning of and the end of the day, just to have a look at what the energy consumption of the pool is overnight as well when it's potentially not being used. And a case study that we've highlighted here is a school where they were excessively ventilating the pool hall. So they found that there was a lot of high electricity consumption by running the ventilation system, which was also extracting a lot of heat from the pool hall, which then obviously needs to be topped up by the heating system. So their temperature and humidity sensors were installed in the exhaust air vents to improve the control of the pool hall ventilation. And for an investment of £14,000 there, the school saw a saving of around £7,000 a year, which obviously resulted in a return on investment of around 2 years. Finally, in terms of technology areas that we want to cover, I just want to have a brief look at the various renewable energy technologies that are available to the majority of schools. The best time to consider renewables tends to be during the design and construction of new buildings or any renovation work. However, there are some opportunities that can be considered at any time. And correctly designed, installed and maintained renewable or low carbon energy systems can potentially obviously save quite a lot of energy and running costs, as well as demonstrating the school's commitment both to the environment and also potentially to providing some practical teaching opportunities as well, depending on the systems that have been installed. So just to briefly run through these, again, we do have various Carbon Trust guides on these specific technology areas, so I would always refer you back to those for more detail. They can be accessed via the Carbon Trust website. So just to run through them, solar thermal technologies. So this is a fairly simple technology, which basically uses dark surfaces to absorb heat from the sunlight and daylight, and to heat water. This is tends to be best utilized as a preheat for hot water systems, and is typically sized to heat the peak hot water requirements in the summer. Solar photovoltaic systems. So similar to solar thermal systems, they are usually mounted on the roof, although they can be mounted on the ground as well if you have the available space. So these just use a semiconducting material to convert sunlight into electricity. They are ideally situated facing south and in a safe and fairly secure location. They are, compared to solar thermal, they are fairly expensive to buy and install. But once they are fitted, they have no moving parts and they don't produce any noise. So they are fairly invisible, and they can potentially significantly reduce the electrical load of the school. Wind turbines do tend to be one of the most cost-effective options for electricity generation at a school, although they are also one of the most expensive and fairly intrusive technologies that you can install, just given that they do cause some noise, and they are obviously quite highly visible. But they have fairly high potential energy and financial savings and returns there. Biomass just refers in general to the burning of fuels such as pellets, liquids, or gases. The main benefit of using biomass is that it is a constantly available source of renewable energy compared to things like wind and PV and solar thermal, where you are dependent on the external conditions. It does require a fair amount of space just for storage, and obviously there are some access issues which need to be considered for biomass as well, compared to more conventional systems such as mains gas. And finally, not a renewable technology, but more low carbon one. So heat pumps, be it air source or ground source, are technology which essentially just move heat from one area to another. So sort of like a refrigeration system, just running backwards. But the benefit of these is that they often use less electricity to heat the they use less electricity than they actually than the energy that they provide. So, as I say, that is a fairly quick run through of the various opportunities that exist in schools, both in terms of energy efficiency improvements and renewable technologies. What I want to do now is just run through the Green Business Fund, which is a scheme that is currently being offered by the Carbon Trust to small and medium-sized businesses and to schools. And there are various services that we do offer through this scheme. So as I say, available to schools, as you can see on the slide there. It is essentially a fund that is available on a first come, first served basis. So each of the Green Business Fund services is available while funding does last. That fund is currently predicted to remain available certainly until the end of the year. We are always looking to try and potentially extend this, but just to stress that it is a finite pot, so it does operate, as I say, on a first come, first served basis, and is particularly targeted at supporting the most cost-effective, high-quality energy reduction projects that are available to businesses and to schools. Hopefully, it is a scheme that encourages businesses and schools who haven't maybe yet taken any action to reduce energy consumption. And there are a range of various services that we offer to do this that I will just briefly run through now. So the first thing to highlight is that the Green Business Fund offers energy efficiency training through 2-hour workshops that are hosted across the UK. So these workshops outline energy efficient behaviour and equipment to help businesses and schools reduce energy consumption. And as you can see on the screen there are 4 workshops coming up in the autumn there. So these are in Bath, Cambridge, Hertfordshire and Chippenham. The Green Business Fund also offers a couple of different services that are provided by members of the technical team, like myself. So these are tend to be either opportunity assessments. So this would be where a consultant is assigned to the school, depending on the size of the school, to provide either remote or on-site support in the form of an energy audit. And these audits will typically highlight the top 3 costed energy saving recommendations that are identified through the audit. It will highlight the next steps to realise these savings, and is available to SMEs within qualifying geographies. The other service that we offer to schools maybe where they have already carried out internal audits, or they've already had external audits carried out, and they know which measures they would like to implement, then we can offer up to 5 days support by a Carbon Trust consultant to help them implement those measures. So this is essentially a procurement support service where we would work with the school to go out to tender to some different suppliers to provide quotations and proposals for an energy saving project, which the Carbon Trust consultant would then review and discuss with the school. This is a service which is aimed at normally medium size organisations and larger schools. The Green Business Fund also offers a capital contribution that can be accessed by schools towards the cost of the installation of energy efficient equipment. So this is a contribution of up to 15% towards the total project cost. There is an upper limit of £5,000 per school. There is also a lower limit of £750 capital contribution. So essentially, if we work on the basis of a 15% contribution, then that would mean the project had to have a minimum capital cost of £5,000. As I say, the Green Business Fund is aimed at projects with a short-term payback, so that's defined as a payback of under 5 years. And projects need to be delivered by a Carbon Trust accredited supplier that can be found on the Carbon Trust Green Business Directory that is available via the Carbon Trust website. Evidence needs to be required prior to the transfer of funds. So the school, if it did have a project that it wanted to go ahead with, would need to apply for the capital contribution before actually accepting any proposals from suppliers. So that relates to the final point there, that we can't retrospectively fund any energy efficiency projects. In addition to the sort of core Green Business Fund services that we've outlined there, there are some additional services that we can offer to some organisations and potentially to some schools. So just very quickly, these are a virtual energy manager service, similar to the energy efficiency workshops, where we would remotely deliver 6 structured and tailored modules to the organisation, or as I say, the school. Again, that would be delivered by a Carbon Trust consultant. We also offer technical webinars, so just the same as we've gone through this morning. There are various webinars that have been delivered by some of my colleagues that are currently available on YouTube, and these are based around some different some different energy saving technologies. So these may well be worth having a look at. And finally, we also, as I've referred to, have various publications and Carbon Trust guides that are also available via the Carbon Trust website, and can provide quite a useful overview of things like energy management best practice or specific technology areas as well. Finally, just on Green Business Fund, something we've been developing a little bit more recently is organizational carbon footprint calculator. So this is something we've developed to support SMEs and schools to report their carbon footprint. And as I say, that is something that is available via the Carbon Trust website. Lastly, if you are in a position to be making any upgrades in terms of energy efficient equipment, then we would always advise to make sure that you select equipment from the energy technology list. So this is a government approved list of the most efficient products across 57 technology areas. And it also offers the opportunity, if you pay income or corporation tax, to claim enhanced capital allowances on the purchase of this equipment. And there is a link on the slide there, which will be shared following the webinar for anyone who would like a bit more information on the energy technology list. So that brings us to the end of today's webinar. So I'd just like to say thank you to everyone for listening.